Now we come towards variation of pressure at 2 points in the different heights or depths. So pressure for two different heights or depths. Consider 2 points A and B separated by small vertical height, dz. So what is dz representing? A small vertical height. We can also take it as dh instead of dz, but however, we can take it as dz. Imagine that horizontal area delta SA and delta SB containing those points, that is the area of those points. Consider the fluid enclosed between the two surfaces, delta SA and delta SB, and the vertical boundary joining them so that delta SA and delta SB that is equal to delta S. Means that is delta SA is also delta S and delta SB is also delta S. Now, in the given figure, the point A and B are in the vertical plane. At point B, the force acting vertically down will be FB and the force acting vertically up will be FA. This FA may be possibly the buoyant force, and dz is a small separation between A and B. So if we will like to find the pressure at point B, pressure will be force over area, and area we have taken as SB. So pressure will be FB over SB, or we will say the force will be pressure multiplied by SB, and same concept we will apply at the bottom. Now we come to the next context. The vertical forces acting on the fluid FA vertically up at SA and SB vertically down at delta SB, and weight means force. So weight will be given as mg, where m is the mass of the fluid and mass is density into volume. Mass is density into volume, and W of the cylindrical fluid vertically downward. Now the same figure we are again considering, and we are taking a cylinder that is vertically downward. The force will be FB and upward it is FA. dz is representing a small distance dz. Now FA will be equal to FB plus W because A point is a lower point. So net pressure acting or net force acting at point B will be, at point A will be FB plus W, where W is the weight vertically downward, that is the weight of the liquid. So pressure at A is P and that at B is P plus dP. So B pressure will be P plus dP. dP is a small change in pressure. So P delta S is P plus delta P into delta S. Basically, we are multiplying the pressures and areas, which gives the value of force. That's why we have written P delta S is equal to P plus delta P multiplied by delta S plus rho. Rho stands for density multiplied by area. dz is small distance and g acceleration due to gravity. Basically, concept used in this equation is that pressure is H dg and density is replaced by, that is, mass over volume. So rho is the density of fluid, or dP is equal to minus rho g dz. ds is small distance. Now, if you wanted to find the total pressure, we have to integrate dP both sides. During integration, rho will work as constant and g will also work as constant. So basically, in the right side, we have to integrate z, and in the left side, we have to integrate dP. Now, we come to the next concept. As we move up through height dz, the pressure decreases. So at the higher points, the pressure will decrease, and at the lower point, the pressures will be more. So for the lower pressures, we have to add certain quantities, and for the top pressures, we have to reduce certain quantities. Now consider 2 points at Z0 and ZH. If the pressure at Z0 is P1 and that at Z is H is P2, then we have to integrate dP from the limits P2 to P1. Higher limit is P2, lower limit is P1. When we will integrate dP from the limits P1 to P2, we will write like integration 1 dP, and 1 dP will be P. So P will be computed with the powers, that is P1 and P2. So we have integrated a function dP, that is 1 dP, that is equal to P. Then we have put the limits. First we put the higher limit, then we put the lower limit. So it will become P2 minus P1. But towards the right side, it is written integrate from 0 to h minus rho gz. This I have explained earlier. We have to integrate to take the complete pressure. Now, when we integrate minus rho gz, minus rho g will be taken out, a common factor, and we have to integrate 1 dz, and integration of 1 dz is z. Then we put the limits and it will become h minus 0, and obviously it will be h. So P2 minus P1 is equal to minus rho g h, or P1 equal to P2 plus rho g h. If h be the variation in depth of the 2 points, then rho g h will be the variation in pressure at those points.